Welcome to Flip Lesson 80 for the 5th grade. Today we're learning all about primes. Not Optimus Prime and all the different Transformer primes. However, he's definitely here to help us out to understand what a prime number is all about. And so on the screen you see a table that would be good to put into your notes as we look at the first 7 numbers in our numbering system, numbers 1 through 7. As we look at these numbers, we can talk about a couple different ideas. First idea we want to look at is the idea of factors. Right? Numbers come with factors. Factors, of course, if you remember, are numbers when multiplied together equal a product. So in this case, our number over here would be our product, and so the factors would be what numbers when multiplied together equal that product. And so in this case, number 1, the factors of 1 are 1. 1 times 1 is the only way to get the number 1. We look at the number 2. If we were to have a multiplication problem with the number 2, we would have 1 times 2. And that's the only combination. And when the only combination ends up being the number 1 and the number that it creates, in this case the number 2, you have what is known as a prime number. So if you look at number 3, we see you have the number 1 times 3 gives you the number 3. So once again, you have a prime number. Right? And as we look down the list, right, 4 you see has 3. Right? So that would not be a prime number. All right? Since we have 1, 2, 3 different numbers there, in the end, what you have is what's known as a composite number, because it contains more than 2 factors. More than 2 factors. All right? So then as you look at number 5, you see you have 1 and 5. So once again, we have a prime number. And number 6, right, we have 4 factors, right? 1 times 6, 2 times 3. That's both of those are going to get you to 6. And so once again, you have a composite number. And then finally, as you look at the bottom, you see the number 7. You see 1 and 7. So that would be a prime number again. All right. So Optimus is helping us figure out primes. Let's apply this knowledge. All right. All right, we got another prime helping us out here. It says the first 4 prime numbers are 2, 3, 5, and 7. We just explored that a minute ago. Now the question asks, what are the next 3? And so to do this, I've taken the time to produce a number line for us, right? We've identified our first 3. So as we look at these numbers, we can see we have 2 and 3. Somehow I accidentally circled 1. 1 is not a prime number, right? We have 2, 3, 5, and 7 so far. So now we want to keep going down the line and figure out prime numbers, right? We look at the number 8, right? 1 and 8, but also 2 and 4. So that can't be a prime. We look at the number 9. 1 and 9, but also 3 times 3, right? 10 is an even number, right? All even numbers are divisible by 2. So we can basically just cross out all even numbers and say, you know, once you have an even number, they can't be prime. All right? Technically, 2 is the only even prime number. All right? 9 we said has factors, so that can't be one. 11, hey, there it is. There's 1, right? 1 times 11, that's the only way to get 11. 13, yeah, that's 1, right? 1 times 13 is the only way to get 13. 15, no. 3 times 5, so we have 1, 3, 5. 17, yes. And so just like that, we found our next 3 factors. And we can continue going, and hopefully you can see that 19 is also 1, 21 is not, and 23 is. So we have that idea. All right, the second part of this lesson has to deal with, well, what about those composite numbers? Composite numbers, right, they have more than one factor. And when it comes to composite numbers, we can do what's known as creating arrays, or picture symbols that help us understand how these numbers work. So I took the number 4, I wrote out the factors for you, right? 1 times 4 and then 2 times 2. And now we want to create arrays. Arrays are basically arrangements of how the factors work to come up with our number or our product of 4. So you see the first example, right? I have 4 little squares here. Right? So I have a total of 4. And they go 2 by 2, right? Because 2 times 2 equals 4. And so we have an array like that. Another way to express that, right? I went up 1 square over 4 squares, right? The height is 1 and the width is 4. And so this becomes another array because 4 times 1 also equals that idea. So let's try this out with the number 12. It says, what are 3 arrays for the number 12? In the end, the first thing we got to do is we got to figure out our factors, right? 12 has a certain number of factors. We know it's going to have a factor of 1 and a factor of 12. But are there any other factors that goes into this? The next thing I'm going to say is, okay, I see the number 12 and all even numbers are divisible by 2. Right? So 2 is there, and 2 times what equals 12? That would be 6. And so that's going to work. And then hopefully you can see that, okay, well, what about the numbers in between 2 and 6, right? I have 3, 4, and 5 left. 3 goes into 12, so 3 times 4 equals 12. And of course, 5 does not go into 12. And so in the end, 12 has the factors 1, 2, 3, 4, 6, 12. And so we want to create arrays based off this, right? So we're going to have an arrangement of a 12 times 1, right? A 6 times 2, and a 4 times a 3. Because those are the 3 different ways that you can create the number 12. Right? And so you can see how these arrays would then look. Right? As I've created the arrays for you, right? We have a 6 by 2, right? 2 high, 6 wide, right? That equals 12. We have a 3 high, 4 wide, right? That becomes an array of 12. And then, of course, you have the 1 by 12, just like you see here, which, of course, equals 12. And so you have that idea. All right, then, here are your sample problems to get you working with, first of all, prime numbers and identifying primes, all right? Don't be deceived by those Decepticons, right? And accidentally mark a composite number, all right? And then, of course, after you've worked with prime numbers, go ahead and draw the arrays for the number 8. And so we have that idea. That is lesson 80, looking at prime and composite numbers.